Okay, we'll look at some of the homework problems that are in section 4.3. Like in this case, problem number 1, the following sets of ordered pairs are functions. Give a rule that describes each function. Like in this first one, you have 9, 18, 10, 20, 13, 26, 14, 28. And you want to find out which one of these four rules describes the first function. Well, take a look at 9 and 18. Well, if you double 9, you're going to get 18. Double the 10, you're going to get 20. Double 13, you'll get 26. And double the 14, you're going to get 28. So in this case here, we're doubling the input number. All right, take a look at the second one. Choose the rule that describes this function: 9, 81, 10, 100, 13, 169, 14, and 196. Well, if you square the 9, you're going to get 81. Square 10, you're going to get 100. Square the 13, you'll get 169. And square 14, you'll get 196. So in this case, we're squaring the input number. That's answer A. And then part C, we got 14, 12, 13, 11, 10, 8, 9, 7. Now, compare 14 and 12, we're subtracting 2. Compare 13 and 11, we're also subtracting 2. Compare the 10 to the 8, you're subtracting 2. And compare the 9 to the 7, you're subtracting 2. So in this case here, we're subtracting 2 from the input number. Okay. All right, let's look at number 2. Where in this particular case here, we're asked which of the following are functions from the set 1, 2, 3 to the set A, B, C, D. If the set of ordered pairs is not a function, explain why not. All right, let's look at part A. It's a set of ordered pairs 1A, 2B, 3C, 2D, a function. Now, by looking at this, we can see that 2 is paired with B, and 2 is also paired with D. In this particular case, it would not be a function. And the reason for that is that the element, and by the way, this is going to be in a drop-down menu, 2 goes to B and D. Because 2 goes to B and 2 also goes to D. Now part B, in number 1, is a set of ordered pairs 1A, 2B, and 3C, a function. Now here 1 is only going to A, 2 is only going to B, and 3 is only going to C. So it is a function. And the reason for that, because we can come up with a 1-to-1 correspondence between the two sets. And this right here is 1-to-1. They'll have the word 1-to-1 spelled out. All right, problem number 2. If a health club charges a one-time fee of $280 plus a membership fee of $35 per month, answer the following. What is the total fee for a 1-month membership? Okay, for a 1-month membership, that's $280 plus this person is going to pay for a 1-month membership, so that's $35 per month. So 280 plus 35 would simply be $315. So for a 1-month membership, that total cost is $315. And then in part B, we're asked to write the rule for computing the fee for an nth month membership and choose the correct answer below. Well, $280 plus $35 per month would be this expression, 280 plus 35n. 280 plus 35n. Right, number 4. Consider the two function machines that are placed as shown, and these are the two function machines that we're looking at here. Find the final input for 0, 5, and 12. Let's start with 0. The output for 0 is going to be this. If we put 0 in, you're going to get 10 times 0, which is 0. So the output is 0. And then this function is g of x is x plus 5. If this is 0, then 0 plus 5 will end up being 5. So the output for 0 is 5. And then next, the output for 5 is this. If we input the 5, then f of 5 will be 10 times 5, which is 50. And then that 50 will be your input for g of x, which is x plus 5. So if that's 50, then you'll have 50 plus 5, which will be 55. So the output for 5 is 55. And then the output for 12, we input 12, you have 10 times 12, that's 120. And then that 120 will be your input for your g of x. So now you'll have 120 plus 5, which is 125. So the output for 12 is 125. And this is one of those examples of a function machine that deals with the composition of functions. All right, take a look at number 5. Let's say we have this graph here on the right, and we want to determine if that graph is or is not a function. And in this case here, it is a function. So when you fill this in using the drop-down menu, the graph is a function. And that is because for each input x, so for each input called x, there is one value for y. And here's why. Okay. For 1, there's only 8. For 3 is 6. For 5 is 4. For 7 is 6. And for 9 is 8. We have a different x value for each of the y values. So that is a function. And finally, number 6. Which of the following are functions from the set x, y, z to the set a, b, c, d? If the set of ordered pairs is not a function, explain why not. Here's part A. Is a set of ordered pairs x, a, y, b, z, c, and z, d a function? Well, by looking at this, we see z is paired with c, and z is also paired with d. So this would not be a function. And because it'll tell you that the element called z goes to c and d. Because z is paired with c and z is paired with d. And part B is a set of ordered pairs xa, yb, and zc a function. In this case, again, well, it is a function. It is a function because x is only paired with a, y is only paired with b, and z is only paired with c. And in this case, the reason for that is that there is a one-to-one correspondence between the sets. And with these, you're given a choice of answers. in problem number 6. That should be enough to help you do some of the problems that are in section 4.3 on the actual MyMathLab system.